Hello everybody. This is my fifth video in a series of SAT Math Review. Today, we will be covering our final fundamental skill in algebra, solving for and interpreting linear inequalities. Okay, so this problem states that the point 8,2 in the xy plane is a solution to which of the following systems of inequalities? So, if we look at all of our answer choices, we can see that they are evaluating these two values with respect to the value 0. So before we even just plug into these different answers, we can try and set up our own system of inequalities to try and then match it with our answers. So we know that 8 is greater than 0 as a positive value, and we also know that 2 is greater than 0. So if we know that, we can also say that x is greater than 0 and y is greater than 0, which is answer choice A. Okay, so this is our first word problem, and based off of the provided information, we have to create our own equation. So it tells us that a cleaning service that cleans both offices and homes can clean at most 14 places per day. Then it is asking us which inequality represents this situation, where F is the number of offices and H is the number of homes. Now, just looking at our answer choices, I can already eliminate both C and D, because if it's at most 14 places per day and it's both offices and homes, you would be adding the offices and homes together. You would not be subtracting homes from offices. That just doesn't make sense with the context of the question. So C and D are out, so now it's between A and B. So we know that it's F plus H, and because it's stating that they can clean at most 14 places per day, that means it can't be anything above 14. So they could clean at a maximum 14 places, or they could clean 13, 12, 11, etc. So we know that the overall number of homes and offices they clean is less than or equal to 14. So we can pull off that sign, and we get F plus H is less than or equal to 14, which is answer choice A. Okay, so in this problem, it is stating that in North America, the standard width of a parking place is at least 7.5 feet and no more than 9 feet. A restaurant owner recently resurfaced the restaurant's parking lot and wants to determine the number of parking spaces in the parking lot that could be placed perpendicular to a curb that is 135 feet long, based on the standard width of a parking space. So then, it is asking us which of the following describes all possible values of n. Okay, so we're already given the minimum value of the size, the width of the parking space, and the maximum value of the width of the parking space. So we can then divide 135 feet long, which is the length of the curb, by these two values to determine the maximum and minimum values of the number of parking spaces. So we'll take 135 divided by 7.5, which is 18. And because that is our smallest value for the width of the parking space, that will be our maximum number of parking spaces. And then we'll take 135 divided by 9. And because that's our widest parking space, it will also be our minimum number of spaces. And for that, we will get 15. And so with these two values, we can then describe the possible values of n. So n is greater than or equal to 15, and it's less than or equal to 18, which is answer choice D. Okay, so in this problem, we are given a system of inequalities. We are told that y is less than or equal to x, and y is less than or equal to negative x. And we are being asked which of the following ordered pairs is a solution to this system. And so for it to be a solution, it must be true in both cases. So the way that I would approach this is just start plugging our points in. So let's start with A. So A is 1, 0, and so that would be 0 is less than or equal to 1. So far, so good. Moving on, we will get 0 is less than or equal to negative 1. Not so good. That is not true. 0 is greater than 1, negative 1. So we can eliminate that as one of our answers. Now, for B, we can plug in again, and we will get 0 is less than or equal to negative 1, which is the same problem we had here because it's not true. So we can eliminate B. C, we will get 1 is less than or equal to 0, which is not true. 1 is greater than 0. And so that only leaves us D, so that must be our answer, but I'll just check it to be sure. So we will get negative 1 is less than or equal to 0, which is true. And we'll also get negative 1, once again, is less than or equal to 0. So we get the same thing, so D is our final answer. Okay, so in this question, it is a word problem again, but this time, not only do we have to create a system of inequalities, we also have to solve for a certain variable in that system. So, the question states that a cargo helicopter delivers only 100-pound packages and 120-pound packages. For each delivery trip, the helicopter must carry at least 10 packages, and the total weight of the packages can be at most 1,100 pounds. With that in mind, what is the maximum number of 120-pound packages that I can carry per trip? So starting off, I would like to just define our variables. So I will say that x is equal to the number of 100-pound packages, and that alternatively y is the number of 120-pound packages. So starting off, we are told that they must carry at least 10 of these packages. So we can create the equation x plus y is greater than or equal to 10. So that is our first equation. And we also know that it can only carry up to 1,100 pounds, and we know that x is 100 pounds, so 100x, and y is 120 pounds, so plus 120y. And that is less than or equal to 1,100. Now, since we're trying to find what y is, I'm going to solve for x in our second equation so we can then substitute it back in. So we will get x is greater than or equal to negative y plus 10. Now, what I am then going to do is plug that into our first equation. So we will get 100 times negative y plus 10 plus 120y. is less than or equal to 1,100. Multiplying that out, we get negative 100y plus 1,000 plus 120y is less than or equal to 1,100. Adding everything together and subtracting 1,000 from both sides, we will get 20y is less than or equal to 100. Finally, dividing by 20, we get y is less than or equal to 5, which is answer choice C. Now, in this problem, we are once again given a system of inequalities, and it is asking us which point is a solution to this system of inequalities. Now, we are told that y is less than or equal to x plus 7, and y is greater than or equal to negative 2x minus 1. Now, the way that I would approach this, like we did earlier, is to plug in our points and see if they're true or not. So let's start with A. So that's negative 14, 0. So that would say 0 is less than or equal to negative 14 plus 7 is negative 7, which is not true. 0 is greater than negative 7. So A is incorrect. For B, we will plug it in once again. So that would be saying negative 14 is less than or equal to 7, which is true. And then plugging it in for our second equation, we would get negative 14 is greater than or equal to negative 1. That one is not true. Negative 14 is less than negative 1, so B is incorrect. Trying answer choice C, we will get 14 is less than or equal to 7. Once again, this is incorrect. 14 is greater than 7, so it is not answer choice C. And while we now know it is answer choice D, let's just confirm it to be 100% sure. So that would be 0 is less than or equal to 21, which is true. 21 is greater than 0. And plugging into our second equation, that would be 0 is greater than or equal to negative 29, which, once again, is true, giving us answer choice D. Okay, so in this question, it is a free response question, and while you could approach it in a lot of ways, there is one specific way I would approach it. So it states that a number x is at most 2 less than 3 times the value of y. If the value of y is negative 4, what is the greatest possible value of x? So first off, what I want to do is create an inequality describing the situation here. So we are told that x is at most something. So that means it is equal to or less than whatever this is. Now, it's 2 less than 3 times the value of y. So 3 times the value of y, that would be 3y. And then 2 less, we would subtract 2. So x is less than or equal to 3y minus 2. Now, it is giving us our y value as negative 4, and with that, what would the greatest possible value of x be? So we would just plug in negative 4 into this equation, and we get 3 times negative 4 minus 2, which would be x is less than or equal to negative 12 minus 2, and x is less than or equal to negative 14, which would be our final answer. Okay, so for our final question, we have a bit of a lengthy word problem. So it states that a psychologist set up an experiment to study the tendency of a person to select the first item when presented with a series of items. In the experiment, 300 people were given a set of 5 pictures arranged in random order. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first one, and among the remaining 150 participants, P people chose the first picture. If more than 20% of all participants chose the first one, which of the following inequalities best describes the possible values of P, which again is the people in the last 150 who chose the first picture in the set? So we know that we will be looking for something in relation to that 20%. So we know it's 0.20. And that there were more than 20% participants who chose the first picture. So that means that whatever there is on the left side is greater than 0.2. And so we know that there were 300 in total, and that of the first 150, 36 chose the first one, and the last 150, P chose the first one. So we will take 100, we will take, apologies, 36 plus P, and divide that by the total number of participants to get our percentage. So that would be over 300. So we know that, and so now we have to just solve for what P would be. So multiplying each side by 300, we get 36 plus P is greater than 0.2 times 300. And then if we look at our answer choices, we'll actually see that it matches up with answer choice D, which is P plus 36 is greater than 0.2 times 300. So our final answer is D. Thank you all so much for watching, and I wish you the best of luck on your SATs.